we have had a lot of different attachments over the course of our project. These include the home delivery containment attachment and what I like to call the cargo box basin. It holds cargo boxes to efficiently complete the mission 16, where you have to load crates into circles.
This attachment is used to knock down the bridge and was used to move the crane to be able to complete both of those missions. This attachment hooks on like this and will be right next to the robot as it travels along. The next two attachments are already on our robot. In the back, this attachment will flip over and is able to do the bridge and will also be used to complete the cargo crane mission. And this front attachment is used to complete the airplane mission to pull the lever down and get the box out of the plane.
The attachments that I have here hook on like so, attached to the arm for this first one, like so. You can see that. And my cargo basin attaches to these front two holes, just like so. There is our robot, fully decked out in all of its attachments. Looks absolutely stunning in my opinion. There were many things with our coding that did not end up working. All of our runs had something wrong with them throughout their span of being created and finished. Run 1, the cargo plane would never completely finish its journey downwards. For Run 2, the cargo ship and the airdrop missions were never finished. For Run 3, the alignment was always a constant issue. For Run 4, we had a lot to fix, including the angles, the speed, and the trajectory in general of the robot. For Run 5, there wasn't really much of an issue, just a little bit of alignment. And Run 6, the robot would always knock over the black panel when we did not want it to do that. We also had several designs that did not work, including this one I have here, a hook design. The hook was intended to complete mission 3.
One of the biggest things I learned during the season was line tracking. I had no knowledge of it beforehand, but it has definitely benefited us in many of our missions.
In coding, I learned how to use gyro straight to navigate around the field and allow our robot to complete many of the missions that we were unable to do without it.
We also got better at working as a team, because we had a lot of struggles with that, and our teamwork was not the best when we first started.
Our teamwork allowed us to solve many of the issues that we had in the first start to get to where we are today.
My favorite mission was unloading the cargo ship because it shows on a miniature scale of how the thing works in real life, and also I like how the crane moves.
My favorite mission was probably Mission 11, Home Delivery, because it shows how the future of delivery will turn out. It shows how robots can now automatically deliver packages to homes, and it was also the most enjoyable to code. I spent nearly 5 hours on it, making it perfect, and I did not get tired of it one bit.
My favorite mission was probably accident avoidance, because I loved the coding and I also liked how challenging it was to only knock over the yellow part. I also think it's really good because in real life, that's actually a really important part of it in both cargo carry and just general traffic.
My favorite mission is Mission 14, the bridge. I think it is symbolic of how bridges are used in transportation on a larger scale today.
Hello, we are Team 53070. I am Regis.
I am Blake.
I am Riley.
And I am Ryan.
Our problem that we chose for our innovation project is imprecise packaging. Large packages for small products waste materials, increase cost, and waste delivery space.
Delivery space is very valuable because it allows more packages per trip. less fuel usage, and it reduces costs overall.
The more cardboard that is wasted, the more companies spend on unused packaging. Companies spend around $150 billion per year on all packaging. 50% of US packaging ends up in landfills. Reducing size will also reduce packaging in landfills. Packaging, becoming litter and waste, destroys the earth that we all live on. The destruction of our earth will mean the demise of our species as a whole. The prevention of climate change will ensure life on our planet so future generations can enjoy this beautiful earth that we all take part of.
However, we must not worry ourselves too much because there is a solution to the issue. While the outcome may seem grim if we do not act, we have the ability to act soon, if not today. We have two ideas in mind on how to fix these issues we face in our modern society. Our first idea is to create more properly sized packaging for specific products. If a company produces many of a specific product, they must create packaging specified to that product.
Even if this is inefficient in the short term, the long-term benefits will outweigh them quickly by saving shipping area and drastically lowering costs.
For instance, if a company mass produces vacuum cleaners, they must tailor packaging to fit vacuum cleaners easily and efficiently. This will allow less packaging to be wasted than if they had been using stock sizes.
Our second idea on how to improve cost efficiency is reducing the thickness of the packaging. Even if the thinning is as small as 1% of the box, that will save 10,000 pounds of packaging per million pounds. That is a major difference in the grand scheme of things. This will allow more packaging to be reduced and will make the packaging more efficient. This will help with the issue of efficiency posed by having produced custom tailored boxes for the products. Less material will be used and the planet overall will benefit. It may seem costly or wasteful at the start, but the end result will surely be worth it. Cut.
These papers show all of the ideas we came up with for the innovation project. Our ideas range from new forms of energy to power vehicles to drone delivery to precise packaging. We were able to eliminate these ideas down to the ones we were using.
Here is a diagram of our innovation project. It shows how packages will be smaller and how there can be more packages on each trip. We also show how packaging can be thin.